Guys, welcome back. So right now we're going to look at then the concept of the addition and subtraction of exponential expressions. So remember our mind map, we've been looking at the concept of exponents together with its laws and the definitions. And then when it comes to expressions, we've then dealt with the multiplication and division. Now we're going to mainly focus on the addition and the subtraction, right? So when an exponential expression includes addition and subtraction, the main thing that we use here is called factorization, right? I know you guys run away from this because at times it becomes a problem, but now we're going to do it with exponents. Now, the first one, or the first very common method, is the common factor type of factorization, and then any other type of factorization depending on the expression that you have at that time. Now, the important principles to note will therefore be, remember, a to the exponent of m plus n is the same as when you were multiplying powers of the same base, which is a to the exponent of m times a to the exponent of n. So it's like you are reversing it, right? Because remember, when it comes to the law, I give it to you like this, as a to the exponent of m times a to the exponent of n. Then you need to come this side. But with this one, it's like you are reversing it. So I'm going to give you something with exponents added. Then you will need to use the word, this thing called splitting them, but using this principle. The other one is a to the exponent of 2x is the same as a to the exponent of x, all raised to 2. Remember the law of brackets that we spoke about, which has to do with multiplying those exponents. So simplifying using factorization, the common factor type will be, we normally factorize, or we often factorize this using taking out a common factor, right? When you're taking out a common factor, it is when we see something that is common in those terms that we are dealing with, right? It might be 3 terms, it might be 4 terms, as long as there is one thing that's common throughout. Not common just on the first 2 terms and then the last 2 terms do not have anything. And then you act as though you're taking out a common factor for everything. Now an example of this will me having 2 to the exponent of x plus 2 minus 2 to the exponent of x minus 1, right? So remember the principle that I just showed you now. This can be split into 2 powers of the same base. This can also be split into 2 powers of the same base. And that will therefore give you 2 to the exponent of x multiplied by 2 to the exponent of 2 minus 2 to the exponent of x multiplied by 2 to the exponent of minus 1. And you then take out a common factor, which is the 2 to the exponent of x on both terms. Now, with the concept of a common factor, guys, remember with a common factor, when you take it out, right, you take each term from the expression and you then divide that by the common factor that you took out. That's the concept of a common factor. You don't just scratch out and then, because if it's just the common factor itself, some people then don't write 1 that's remaining. They then write 0 because they're thinking they cancel out. No, you definitely need to take each term and divide it by the common factor in order to get what is remaining after that. So what I will be left with, if I divide the first term by the common factor, will be 2 to the exponent of 2, and then the second term will be 2 to the exponent of negative 1. Now, factorizing using what we call the difference of 2 squares, if I have 3 to the exponent of 2x minus 9, this is the same as 3 to the exponent of x all squared minus 9. So remember that this is a difference of 2 squares. It's the same as me having x squared minus 9, right? Then I can then factorize that using the difference of 2 squares, right? This is just an approximation just to show you what it means. Now, we then also have what we call the quadratic trinomial. Now, this is the special kind of factorization when it comes to the concept of exponents. Here, guys, the main thing that you need to make sure that you understand is your first term, the exponent for the first term must be such that it is always twice the exponent of the middle term, right? So I will repeat. The exponent of your first term must always be twice the exponent of your middle term. Then that's a quadratic equation. Why am I saying this? Remember, just from algebra, x squared plus x minus 2 maybe, right? The first one is x squared. The exponent is 2. The middle term is just x. The exponent is 1. Therefore, 2 is twice 1. That's what I really mean here. Always make sure you don't use opening binomials here when that's not the case, right? If I give you maybe 1 over 2 and then I give you 1 over 4, then you look at what exactly is it that is happening there. Is this twice that? If not, then employ another method and not necessarily the factorization method. So please do note that. But let me show you how you will then factorize this, provided that it is a quadratic trinomial. So you can see this is 2x and that is x. So it shows us that it is twice that, right? So this will be the same as applying the principle that I said was important for you to note. 2 to the exponent of x, all raised to 2. And then you can then see that the first term here is 2 to the exponent of x. So the exponent is the same as that one. But because of this 2 that is outside, it then makes the main principle that I was saying now, it being twice the exponent of the middle term. And then if you factorize this, it therefore becomes the same as 2 to the exponent of x minus 4 into 2 to the exponent of x plus 1. Now, another way just for you to understand this better, right, is you can always just say let 2 to the exponent of x be k. You see, then immediately you know that you now have k squared minus 3k minus 4. This will be easier for you to factorize as opposed to when it's there in this particular form, right? So that's one of the ways you can employ here. But always remember that you let k to be something else. So you don't leave it as k at the end. You always substitute what k was initially, right? So that's one of the ways you can do this. So simplifying addition and subtraction, one common factor, or factorization. Remember guys, factorization is not only about opening two brackets. At times you can take out a common factor. That's also one type of factorization. But I know that I've said a lot, and I'm sure that you guys have also taken down some notes that are important there. But for now, let's just refresh a bit and take a quick break, and I'll be back with some questions for us to practice what we just spoke about.